Number 4, suppose that a liquid is being cleared of sediment by pouring it through a cone-shaped filter. So we're going to have a cone, but it's going to be upside down from what we're used to. And water is going to be poured in there, it's going to come out the other end. Assume the height of the cone is 16 inches. So if I look in here, that overall height is going to be 16 inches. The radius of the base of the cone here is 4 inches. The liquid is flowing out at a constant rate of 2 inches cubed per minute, 2 cubic inches per minute. How fast is the depth of the liquid decreasing when the level is 8 inches deep? So here we're going to have water 8 inches deep. So we've kind of got a cone inside of a cone. This little area right here is going to be filled up with water. And that has a height of 8 inches. So let's kind of go back and take a look at a couple things. It says if the liquid is flowing out, so the water is coming out of the bottom, at a constant rate of 2 cubic inches per minute. So this is a rate of change, right? So this is going to be like a dx dt, dy, d something dt. And what we're dealing with here, we've got radius, height. This measurement is in cubic inches per minute. So we know the minute is time, but cubic inches tells us that's going to be volume. So dV dt, the change in volume with respect to time, is 2 cubic inches per minute. And we've got the height that we're dealing with here is the 8 inches. Not the overall height of the cone, but the height of the water at that time. Now, the radius of that water is not going to be 4, but we can figure that out using a little geometry. Right? If we look at this big triangle for the whole cone, that big triangle, the radius was 4, height was 16. Now we've got a smaller triangle right here where the water is, but that's going to be a similar triangle. We know the height for that is 8. The radius is what we're trying to figure out. You might be able to see that pretty easily, but we'll set it up here. If we look at the radius over the height, 4 over 16, has to equal this radius over this height. So if we multiply both sides by 8, we get a radius of 2 inches. So right here where the water is, has a radius of 2 inches. So we've labeled everything that we have. We need to figure out what are we trying to find. It says how fast is the depth of the liquid decreasing. So the depth of the liquid, or in this case we've used h for the height, we're trying to figure out what's dH dt. We want to find out how the height is changing with respect to time. Now we need to come up with an equation that puts together volume, height, and radius. Well, that's just going to be the volume of a cone. Volume of a cone is 1/3 times pi times r squared times height. This is one that we'll use quite a bit in the next few days. So volume of a cone, 1/3 pi r squared times height. So we've got our equation. Now we want to look at taking the derivative of this with respect to time. We do have one problem though. Well, over here we know what dV dt is. We're trying to find dH dt. We don't know what dr dt is. So without knowing dr dt, that's going to make this difficult. We have some missing information. We won't be able to solve it. So in this case, what we can do instead is replace r. Rewrite it in terms of h. So if we can get this to be just in terms of volume and height, that'll make our job a lot easier. Also, it'll help us, we won't have to use product rule when we do the derivative of this right side. So, to figure this out, and you'll see a lot of problems like this where you do the same thing, we need to write r in terms of h. We look back at these little triangles and these similar triangles over here. If we look at this, we know the overall radius was the radius was 4, the height was 16. If we look at just any old radius and height of like the water when it's filled up. We're just going to do it in general, kind of like we did over here. But the radius compared to the height is going to be 4 over 16, or 1/4. So the radius over the height equals 1 over 4. All that means is the radius is always going to be 1/4 of the height, or the height is going to be 4 times the radius. And we can kind of solve this for r pretty easily. Radius is just going to be 1/4 of the height. Right, so we set up this proportion, and we can take this and substitute it in for r. So now our equation looks like this. V equals 1/3 times pi times 1/4 h. That takes the whole place of r squared times h. So we get 1/3 pi. If we square both of these, 1/4 squared is 1/16 times h squared times h. So now we have 1/3, we can multiply the 1/3 times the 1/16. We get 1 over 48 times pi times h cubed. So it took a little work to do that, but now we have a simpler equation to deal with when we have to go and take the derivative of both sides with respect to time. So we're in that third step of the process. Take the derivative of both sides with respect to time. We get dv dt. Right? Derivative of v with respect to t is just dv dt. Over here, 1 over 48 and pi, those are constants. So we can keep those on front. Times derivative of h cubed, that's going to be 3h squared dh dt. And we could simplify this, but we're going to go ahead and plug numbers in and simplify it anyway. I'm going to go ahead and put in dv dt, I know was 2 cubic inches per minute. So this is 2. Equals 1 over 48 times pi times 3, and our height was 8 inches, so 8 squared dh dt. Alright, I just realized I made the same mistake that I did earlier. So let's back up a little bit here. Remember the change in volume with respect to time, it's flowing out at this rate. So the amount of water in the cone is getting smaller, which means dv dt should be negative. So do the same thing again here. Okay, so that's something you need to look at. Obviously I need to look at it too when I'm doing the problem, but when it's getting smaller, the value is getting smaller, the rate is negative. So here we end up with negative 2 equals 4 pi times dh dt. So we can divide both sides by 4 pi, and dh dt equals negative 1 over 2 pi. Right, if we simplify that, and you can put that in your calculator. Make sure when you do that you put the 2 pi in parentheses. Otherwise you're dividing by 2 and then multiplying by pi. So you should get about negative 0.159 inches per minute.